Okay, this is going to be a pretty short video, and we're going to talk about the M+2 peak. Alright, so the M+2 peak doesn't appear in all mass spectra, but when it does, it can very quickly tell us some useful information. And so, by the M+2 peak, what I mean is, if at the highest end of your mass spectrum, if you have two peaks that one is exactly 1/3 of the other one, and the mass difference is exactly 2 mass units, so that's where the +2 comes from, then this tells me that we most likely have a chlorine atom in our molecule. And so the reason chlorine gives this unique signal is because, unlike carbon, that is almost all carbon-12 and then very little carbon-13 and the other isotopes, chlorine has two relatively abundant isotopes: chlorine-35 at 76% and chlorine-37 at 24%. And so if you notice, right, chlorine-37 is obviously 2 mass units heavier than chlorine-35, and the percentage of chlorine-35 is 3 times that of chlorine-37. So when you have chlorine, it gives us this particular M+2 peak, where this peak that is 3 times higher than this one is due to the chlorine-35, and this peak that's 2 mass units higher, so 35 to 37, but it's a third of the height because of the relative abundance of those two isotopes of chlorine. So anytime you see this pattern where in the parent ion region you have a high peak that's 3 times of the one that's exactly 2 mass units next to it, this is the signature of a chlorine atom in the mass spectrum. So anytime you see this particular M+2 peak, you can be pretty confident you have a chlorine. Alright, another halogen that we can recognize based on the M+2 peak is bromine. And so bromine also has two naturally occurring, relatively abundant isotopes, bromine 79 and bromine 81. And their difference in mass is exactly 2 mass units. And so it also gives rise to an M+2 peak. But because the abundance of these two isotopes are basically the same, this pattern of an M+2 peak is 2 peaks at the high end of the spectrum in the parent ion region that are basically the same height and exactly 2 mass units apart. So when you see 2 peaks with basically the same height at the high end of the spectrum that are 2 mass units apart, then this is a signal of a bromine atom. And that's it. Very short video, but how do we identify bromines and chlorines in the mass spectrum using their M+2 peaks?